So, we're not going to do the actual magic square thing. You can do that on your own if you want. We are going to work through every problem because we need to review every problem. So here we go, letter A. This is our unit 3. That's a major cookie there.
It's the best kind.
Did your mom bring that?
Did Mom make those?
I had to go buy this.
You had to buy that?
Let me see
Homemade
what it
cookies
looks
are better.
That's an infraction.
Drink your late, buddy.
Yes, that's an infraction.
Late by a minute though.
Yeah.
Is it
I
worth
run a little
it? Like,
fast.
I saw it was 45 minutes.
Here's our function.
So, wait.
Didn't make it though.
Close.
And we have to find the value of h of pi. Oh guys, this is easy. All we have to do is plug in pi. So here we go. What's the cosine of pi over 3? That's what my brain is thinking. Is a half. So the secant of pi over 3 will be 2. So 6 minus 5 times 2 looks like the answer is -4. And by the way, I did include the answers in the pattern. All right, B. We have a tan pi x plus b. All right, and we have a table of values shown. So we know that if x is 0, we get 1, 1/4 gives us -1, and 3/4 gives us something, and we have to figure that out. Now, what does this mean right here? What does this right here mean? If we put in 0, we get 1. So let's do that. Let's put in 0 and get 1. If we put in 0, we get 1. Okay, what's the tangent of 0? Think of your unit circle. Tangent y over x. Tangent of 0 is 0. So doesn't this literally say 1 equals d? Because that's 0. Alright, what does this mean right here? If we put in 1/4, we get -1. Alright, so let's go ahead and put in 1/4. Now remember, you already know that d is 1. So we can go ahead and make that a +1. Now what's the tangent? Oh, that's not x, that's pi, sorry. What's the tangent of 1/4 pi? 1. So this is 1. So -1 equals a plus 1. So a equals -2. And the question is, find the value of k, all right? So now I know what my equation is. My equation looks like this, but now I know that a is -2 and d is 1. So how can I find k? Plug in 3/4. All right, so -2 tan pi times 3/4 plus 1. So what's the tangent of 3 pi over 4?
-1.
-1. So this is just going to be 2 plus 1 over 3. Everybody okay with that? You feel like you can do that? All right, what's next? A portion of the graph is shown above, where f of x is a cosine bx plus b. And we're ultimately going to figure out what a, b, and d are. Then we're going to multiply them together and get the answer. So, what can you tell from the picture? D is 1. Can everybody tell D is 1? okay? Because the picture's lifted up one. Okay, so D is 1. Yeah. Can you tell what A is? A has to be, 1, 2, 3, yeah, 4. Now we need to be careful. Is A gonna be 4 or negative 4? Negative 4. Is it A gonna be negative 4, guys? Okay. Can we tell what B is? Well, we have to look at what the period is. So it looks like the period of this thing is 2 pi. And we know that period, this is another thing to remember, for sine and cosine, period is 2 pi divided by b.
No.
So if 4 pi is the period, then yeah, won't.
Wait, it's the period, isn't it?
Mhm.
Oh.
So b is 1/2, just like you said, b is 1/2. So negative 4 cosine 1/2 x plus 1. And what were we doing? Times them together, a, b, and b. So a times b times b. I got negative 2. Good? Oh gosh, D is so simple, but we cannot miss this kind of thing. I'm gonna think about sine. What's the sine of negative pi over 2? Negative 1. What's the reciprocal of negative 1? Negative 1. Yep, negative 1. Oh, here's one of your favorites. What is this gonna be equivalent to? I have no idea. Do you think it's 0? I don't know. I don't think it's 0, but maybe. Let's work it out and see. What am I gonna do? What am I gonna do with the numerator?
Simplify that. Sine
Now remember, this isn't 1. Sine squared plus cosine squared is 1. This is a FOIL. So here we go. So that's going to be sine squared plus 2 sine cosine plus cosine squared minus 1. Is that okay with everybody? It's sine plus cosine times sine plus cosine. Now, this makes 1, right? So these two make 1 minus 1. That's all gone? You with me? So what's left? 2 sine cosine over sine cosine, which is just going to be 2. Okay, is everybody okay with that?
Can you, the stuff you just did, can you explain that, please?
Sine squared plus cosine
No,
squared is 1.
the 2 sine, cosine, just that part, yes ma'am. You said it equals 2. So it's not 2 sine cosine?
Yes. It's like having,
So it's not 2 of the variable?
it's like having 2xy over
Oh,
x.
okay, okay.
If it was square.
Okay? You understand this question? I don't think so, right?
He thought that it'd leave a sine cosine, but that would be if it
Oh,
was
no,
squared.
yes,
Okay.
yes. No, I think it's like half the sign. Okay, letter F. The function is periodic with a period of 8. All right, and we wanna find, we know the period's 8,
Oh, period.
and we wanna find out what f of -7 plus f of 20 is.
So it'd be 14.
Now, I think f of -7 is gonna be pretty easy, isn't it? Because -7 is just one period back from 1. So won't f of -7 be the same as f of 1? Because these are 8 apart. So f of 1 is 14, so this is 14. Now, can I do a similar thing with 20?
Yes.
One option would be to come here, because won't f of 4 be the same as f of 12, be the same as f of 20? So f of 20 is -5. So the answer is 9. Is that okay with everyone? What is periodicity? If you have a period, what does that mean? That means you repeat exactly the same values, in this case every 8. Alright? Now we've got some kind of weird graph shown. How many solutions does the equation here have? Alright, let's solve this. Right hands, are you paying attention?
Yeah.
Okay. That's not quite true, but. Alright. How many answers, that's not correct. What is the answer to this question? This is saying, find the angle whose sine is -√3/2. Now remember, that notation narrows me down. Inverse sine, I can only look over here. And since that's a negative number, I'm looking down here. What angle has that for a sine? -pi/3. Now, Brian, we need to talk about this with you and everybody. This is another thing you have to remember. Inverse trig notation is very specific. Any answer to this question has to be between -pi/2 and pi/2. Those are the rules. So when Brian said 5pi/3, is he in the right spot? Absolutely, 100%. He is in the right spot. He would get the right point. Everything would be perfect, except that notation does not allow 5pi/3. We have to use -pi/3. Okay, guys? Alright, so we've got 3 -pi/3, so we get -pi, which is about -3.14. So look at your graph, and that's a y value, that's y. So -3.14 is down here on your graph. How many points on that graph have a y value of -3.14? 4 of them, I think. Everybody see 4?
Yeah.
See it, Christopher?
Yeah, I'm looking at that.
Okay, alright. H, oh, this is an easy one, you got this one. Which of the polar coordinates is equivalent to -2 3pi/4?
I got 5.
It wouldn't be A, or 1, it wouldn't be 1, because because if you're leaving r -2, your angle has to change by 2 pi. It can't be 2 because if you change the sign on r, you have to add pi. Can't be 3 because the angle didn't change. 4, can't be 4, we didn't change the angle by a whole pi. 5.
That's what I'm thinking.
I'm thinking 5.
Cinco.
Would everybody agree? 5 is the one?
Yep.
Okay. Tan, 5 pi over 4, plus cosecant, 7 pi over 6. Okay, you know how to do this. What's the tangent of 5 pi over 4? Oh, watch it. 1. 1. What's the sine of 7 pi over 6 is -1/2, so this will be -2. So -1, since we're adding them right, -1. Everybody okay with that one? All right, J. The function, okay, so I've got a table value given, and this is a sine function, some kind of sine function, with a period of 2 pi. Oh my gosh, quit yawning, this is fun.
Sorry.
Ate a big lunch.
Too much candy.
It's millions of candy.
All right,
It's his birthday.
what am I doing? I'm trying to find the amplitude of this function. This is a sine curve. Period's 2 pi, and I gotta find the amplitude. Think about, we did problems kind of like this before where we knew that this point and this point are gonna happen half a period apart, right? So if I know the period is 2 pi, then don't these 2 points have to be half a period apart? So we're going from -4 up to 8. Imagine this is -4 and this is 8. So our amplitude has to be 6. Does that make sense to you? Why did I choose to look at these 2 points in particular? Because they're a pi apart. They're half a period apart. Okay? All right. That's K. Okay, now I'm ready for K. Okay. The portion of the sinusoidal function midline C is shown with, oh, easy.
1.
Yeah, that's 1. All right, so a point in polar coordinates is -4/√3, 4 pi over 3. That's polar. And I want to find the y. What?
We only have to do the sign, right?
Exactly.
There's no points to do
So
this, right?
y equals r sine theta. Kids, this is r and theta. So -4/√3 times the sine of 4 pi over 3. What is the sine of 4 pi over 3? -√3/2. Well, that's all gonna work out nicely. All right, let R be the polar function defined by this big equation. average rate of change from 0 to 1/3. Oh, talk about easy. How do we find average rate of change? R of 1/3 minus R of 0 over 1/3 minus 0.
So let's plug in the third.
So let's plug in the third. Alright, so if I plug in the third, I'm going to have 2 cosine 1/3 pi plus 4/9 sine 1/3 pi squared. Cosine pi over 3, 1/2. So this is going to be 1 plus. Okay, what's the sine of pi over 3, or pi over 3?
Just gonna get squared.
So that's going to be √3 over 2, but I have to square that one.
3 over 4.
So that's going to be 4/9 times 3 over 4, which is 1/3. So I got 4/3 for this right here. All right, now I gotta do the same thing with 0. I can probably do this one without writing it all out. If I put a 0 in here, what's the cosine of 0? 1. So I'm just gonna get 2. What's the sine of 0? 0 squared is 0 times 4/9 is 0, so I just get 2 for that one. So when I plugged in a third, I got 4/3. When I plugged in 0, I got 2. Hopefully I'm not making any mistakes. And then the denominator is 1/3. So what's this? This is going to be negative 2/3 over 1/3. I got negative 2. Is that okay? All right. Now we have one that's kind of like one we already did. We have this table of values. We have to build an equation from that. So, all right, the function is given by a cosine 2x plus d. Selected values are shown in the table above. What is the value of a plus d? So I have to find a and d. Thoughts on that?
Well, should we look for our something that's half a period apart?
Well, we could, but I don't think, well, now wait a minute. I don't think we have it this time.
Plug in.
Maybe plug in some points. So, I don't know, let's just plug in pi over 6. If we plug in pi over 6, times pi over 6, pi over 3, this is what we end up with. 6 is a cosine 2 times pi over 6 plus d. What's the cosine of pi over 3? So 6 equals 1/2 a plus d. Now there's nothing else you can do with that at this point. But where did that come from? We plugged in this point. So what can we do now? Plug in another one. So you want to do this? Yeah, let's go ahead and do that one. So if we plug in that one, it says 5 equals a cosine. Now I'm plugging in pi, so it's going to be 2 pi plus d. what's the cosine of 2 pi? 1. So 5 equals A times 1 plus B. What do we have? System of equations. So I'll just subtract this one. So 1 equals negative 1/2 A. I get negative 2 again, didn't I just get negative 2? Oh wait, that's just A. So A is negative 2. Is that right? So then, if A is negative 2, then it looks like D equals 7. Did I do that right? And what am I doing? Adding them together? So the answer would be 5. Okay. All right, now I've got some really strange picture there. Polar function, all values, graph, what is the only integer value of theta where the distance between the polar function and the origin is decreasing? Now, do not be confused. There are lots of places on this picture where it's decreasing, but they said integer values. So, is it decreasing at negative 4? No. At negative 3? No. At negative 2? No, negative 2 looks like a peak to me, right? How about negative 1? No. How about 0? Yes. The curve is decreasing at 0, and that is the only place, integer-wise. I mean, check out 1, 2, 3, 4, 5 if you want, but 0 is the only place that's an integer. All right, and then P, we're probably not going to get it done. I need your thoughts, though. We'll do this one tomorrow, but tell me what you think might be a strategy to this problem.
Use that thing where you move the unit circle. Yeah.
Okay, wait a second. What do you mean?
Unit circle. Unit circle. Yeah. Pi over 3.
Okay, so could we use our special formulas? Guys, we need to talk about this, so quit packing up. Could we use our special formulas, our sum and difference formulas, to find the sine of 7 pi over 12? And this one and that one?
Yes.
Okay. I see a lot of different angles going in there. I think I'd have to do that a whole bunch of times. Could I? Absolutely. Is that the most efficient way of doing the problem? No, it's going to take forever. So what else do you notice?
Can you add them all together?
No, they're not like terms. Here's what I want you to think about. These are all 12s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not even going to space. There's the first 12 12s. Think about an angle at 5 12s and an angle at 7 12s. Are these two angles the same? So the only thing that would be different between 5 12s and 7 12s is whether the x and y were positive and negative. So maybe we will rewrite all these 12s in terms of 1. So pick like 5 12s. We'll write them all in terms of 5 12s. All right, we'll do that tomorrow.
Thank you, Mr. Ford.
You're welcome. I thought you're all hanging on the edge of your seat.
Why can't they be added?
Because they're not like terms. Now, if you evaluated them, like if you got a value for sine 7 pi, cosine, and did the math, they can add because they'd be numbers. But right now they aren't like terms. It's like you can't add cosine 2 plus cosine 3. I mean, if you have number values, you could. There's no way to simplify those two.